Hi, and welcome to the WinDbg Fundamentals User Mode course here on Pentester Academy. My name is Pavel and I'll be your guide throughout this course. Okay, so let's start with the first scenario. Let me run the application. Here it is. And the problem that we've seen is if you press calculate 1, the results seem to be okay. However, the information in the file seem to be missing in numbers. And that's a problem, and we want to see why that happens. So how can we do that? So first, let me attach to the process. I'm going to attach to the process. The process is named primes.exe. Let me attach to it. And as usual, the debugger breaks in the initial breakpoint right when we kind of attach to the process. And I can go ahead and look at the threads within the process. And so the calculation of the prime numbers themselves seems to be fine, but the file seems to be misbehaving in some way. So what do you think we can do here? So one thing we should realize that to write to the file, the API used is going to be the write file function. And so we can perhaps go ahead and issue a breakpoint in that function. But first, let me continue execution for a moment. And when you have a multi-thread application, the first thing you should always suspect is that maybe that multi-threading is giving you problems. And so let's try to remove multi-threading here by changing number of threads to 1 and then hit calculate 1. And we get a result and we get some time. So now we can go ahead and open a notepad again and see whether we have any changes in the results. So I'm going to drag that file again here. And notice now the numbers are ordered, which is of course expected because now we have just a single chunk provided to a single thread. And if you go ahead to the end and look at the number of lines reported by Notepad, we can see that the number of lines is exactly as it should be. And so it seems that with one thread, the operation succeeds just fine. If you go ahead and increase that to 2 threads and calculate that again, and let me drag the new file here again, then if we go ahead and look at the bottom, then we can see already things are not as they should be. We can see that number of lines here is 76,000 something, and we still should get 78,000 something. And so it's already fairly clear that the problem is the problem of synchronization. Something is bad happening and we're losing some of the outputs, which means that probably some write operations on the file are happening at exactly the same time, and one item perhaps kind of tramples another, which means that we're losing some of these numbers. And so if you want to kind of make sure or see that using a debugger, let's go ahead and set up a breakpoint in kernel 32 in the write file function. And I'll also add something like 100 here, which is the number of paths I want to catch that breakpoint. So I don't want to catch the breakpoint in the first write file. I want to catch that with the hundreds, the 100 in line of write file. And why do I want to do that? Because I want the threads to start using some code and running and then kind of catch them in the middle of their work. So I can specify 100 or 1000, doesn't really matter. So let's go with 100 in this case, and again click go. Now let's go back to our application. Let's increase number of threads to 4 for instance, and again press calculate 1. And we get to the breakpoint at some point. And let's see what's going on here. So we are currently in thread number 5. Let's see what's going on with the threads in the process. So we have these number of threads in the process, and thread number 5 here is within the write file function. As you can see here, we have this function in the primes application called calc prime threads 1 that is issuing this write file function. And if I have access to source code, I can also jump to the source code and see that indeed there is a function here and there is a write file here somewhere that we're currently at. So what about other threads? This thread is clearly doing write file, but what about other threads? If I go ahead and change that breakpoint to now be a single shot breakpoint, so not a single shot, but just break for every write file that you get and click go, then we get to thread number 5 again. We can continue that and it eventually will hit in another thread that's doing write file. And again, that makes sense because we're supposed to be having 4 threads here just running around and doing write file as part of their calculation. So let's look at all the call stacks in the process by using the ~k command that I mentioned. Just to get the overview without the need to kind of switch to every thread or list the call stack of every thread in question. And so we see several threads here. Some of them seem to be doing the same kind of work, and some of them are doing something a bit different. And so first we're starting here with thread number 0. Thread number 0 is the main thread or the first thread in the process, and it's the one that's managing the user interface. And that's why we see here stuff that is related to a user interface. We see the main function of primes here, and it calls some function that shows the dialog box. Here's the dialog box function from the Windows API that shows the dialog box, and there's some rendering going on here that we kind of stumbled upon in the middle here. We see there's a paint buffer here, so something is being redrawn here, probably some control. And that's fine, we don't really care about that too much because that thread is not doing the real work. It's not accessing any file here anyway. However, we have these threads like 1 and 3 here, and another one here, another one here perhaps, that are doing the exact same thing. They're all calling the write file function. And remember that the first parameter to write file is the handle to the file. You can verify that by looking at the documentation. And so the handle here should be in the RCX register. And clearly what we have here is a handle called 3A8, and that handle is a file handle. So it says it's a type of a file. So it doesn't provide us with the file name, unfortunately, but it does show it's a handle to the file, and that handle is 3A8. So what about other threads? So if we go ahead and continue execution, again, breaking at the next write file, now we broke into thread number 3. And so in this case, again, let's see what the handle is that write file is operating on. And as we can see here, it's exactly the same handle, which gives us the idea that all these threads are executing concurrently, writing to the file concurrently, and that's precisely the same file. We see the same handle, which means that points to the same object, which in this case is a file object that is being written to. And so because they're writing to the same file at the same time, we have a synchronization issue on our hands. That's why we're getting fewer lines in the output file than we should have when you have multiple threads. We've seen that when using a single thread, that problem goes away. And that's because there's no contention, there's nothing going on that needs to be synchronized. And so the problem with Calculate 1 is the lack of synchronization when accessing the file. That's why we get this kind of problem. And so we'll see the solution. The solution is really about writing the code properly. In fact, Calculate 2 button solves that problem. So we can look at the solution if we wanted to, and we will do that in the next section.